Hello, my lovely physical science students. This is the second part of Chapter 2. This will be the types of bonds. So hopefully this will be a little bit of a review section for you because some of the goals of this lesson will be to describe an ionic and covalent bonds, which we just got done doing on our last test, so you guys are totally pros. Second thing, we're going to identify the particles produced by ionic bonding and by covalent bonding. Third thing, distinguish between a nonpolar covalent bond and a polar covalent bond. So first thing, when we gain or lose electrons. So first of all, every element occurs in a neutral state. We call it an atom. Atoms don't exist very long because elements want to be stable. Yes, they're neutral in charge, but they want to have the stability that other elements do by having their 8 electrons in their outermost shell. So as soon as the atom of that element gets into nature, it's going to automatically gain or lose electrons and become an ion. So this happens naturally in every element, except for those exceptions. Noble gases are our only ones that don't gain or lose their electrons. If they lose electrons, they're going to become positively charged. Those positively charged elements have a name. They're called cations. Cations we can find in groups 1, 2, and 3, and in our transition metals. So just to review, if you are in group number 1 elements have 1 valence electron. They want to get rid of that 1 valence electron, so they're going to lose 1 electron, and they're going to become a positive 1 charge. If you are in group 2, you do the same thing, but this time you have 2 valence electrons. You will lose 2 electrons and become a positive 2 charge. And as you can suspect, group 3 has 3 valence electrons. You're going to lose those 3 and have a positive 3 charge. Easy way to remember that cations are positive is that they have a T in them that looks just like a plus sign. The other type of ion we can form is called an anion. Anions are ones that gain electrons to become a negatively charged ion. Examples of negatively charged ions are going to be some of your nonmetals in groups 15 through 17. So for groups 15, these are going to have 5 valence electrons on their outermost ring. They want to get to 8. So instead of getting rid of all 5 of those electrons, what's going to happen is that these are going to try and gain 3 electrons so that they form a negative 3 charge. Group number 16 will have 6 valence electrons. In this case, they will gain 2 of them, and they're going to have then a negative 2 charge. The last one then, group 17, of course, will have 7 valence electrons. They will gain 1 electron because they're trying to make 8, trying to be stable, and they will have a negative 1 charge. Forming a bond. So this is something that we have done before. We're going to draw our Lewis dot diagrams, and we're going to try and make each atom stable by putting 8 electrons in their outermost ring. So first of all, we want to draw 2 Lewis dot diagrams close to one another. So we'll start with K and I. So K is in group number 1, so we give it 1 dot. I is in group number 7, so we're going to give it 7 dots. So iodine in this case has one empty spot. Instead of iodine trying to get rid of all of these electrons, all it needs to do is fill that one spot. So this one electron is going to come over here and become part of iodine. Because iodine is going to gain a 1 negative particle, it's going to be a 1 negative charge. Potassium lost one of its negatives now, so it will be a positive charge. Look at these two charges. They're equal but opposite chargely. In this case, we do get a neutral compound. That's another thing that elements try to do, is to create neutral compounds. When they bound together, they will exchange electrons so that their charges are balanced. My next one, my Mg has a 2, is in group 2, so we have 2 electrons. Each of the Cl's have 7. So we'll draw one Cl on that side and my other Cl on the other side. So Cl has 2 empty spaces for one of magnesium's electrons and the other one of magnesium's electrons. So gaining 1 electron, this will become negatively charged. Magnesium, on the other hand, will lose 2 electrons to have a positive 2 charge. Again, looking at my charges, I have a -1, -1, and a positive 2. This again does create a neutral compound. So when things bind together, they do so to match up their charges. Ionic bonds. So just a little review. It is a metal with a non-metal bonding together. What happens here is we have a transfer of electrons from one element to the other element. And typically the element that is going to be stealing those electrons, they're going to be stolen by the non-metal element. Because our nonmetals are the ones that have fewer spaces to fill, so they want to steal those electrons to fill that little space. So for example, something like chlorine, the one we just got done looking at. Chlorine is in group 7. It only needs 1 electron to fill its outer ring. It's going to steal that electron from any element that is able to donate 1 electron. So our nonmetals will always steal them. Just like you saw from the last slide, when compounds are made, they become neutral in charge. So the charges of each of the atoms involved will balance each other out. The other thing then is ionic compounds are crystalline solids with very high melting points. So a crystalline solid just means it has a very rigid, orderly structure such that it looks like little boxes kind of stacked on top of each other. So very orderly, very neat. Sort of think of rows in a classroom, just maybe not mine. So a very neat, orderly crystal structure, that's what I mean by a crystalline. So very order, straight rows, kind of like little desks. And they have extremely high melting points. Last kind of bond then is a covalent bond. So just reviewing, a nonmetal with a nonmetal bonded together is our covalent bond. The difference between an ionic and a covalent. Ionic is going to have electrons that are shared. They're shared between the atoms that are bonded. And again, we're going to form a neutral molecule. But in this case, because we are making covalent bonds, we call them molecules. The last slide, let me just go back for 1 second. The last slide, we kept calling our sort of substance we were making? A compound. So compounds have to do with an ionic bond where my molecules are going to deal with my covalent bond. If we have a single bond, that's going to form when one pair or two electrons are shared. So for example, water, H2O. So there is one O and two H's. So in this case, we draw our 6 around our oxygen. Oxygen, if you notice, has two little spaces right here for these lovely little electrons to fill in that space. When that space gets filled in, this electron spends some of its time around hydrogen and some of its time zooming around the oxygen. Whenever we move one of the electrons to create a bond, we draw a line like this. If we wanted to do a shorthand as opposed to putting all of the dots in, a lot of times they just draw a picture with a single line. The single line is going to represent two electrons that are bonded together. And a lot of times we call this a single bond. Because yes, there are double bonds and triple bonds. We call those multiple bonds. Multiple bonds form when more than one pair of electrons are going to be shared. For example, nitrogen, N2. Ooh, what is special about that N2? Ooh, yeah, it's one of our diatomic elements. Most definitely. So there are 7 of them, remember, it's our lucky 7. So you start at nitrogen, you go over and down to make a 7 on your periodic table. But let's focus on our multiple bond situation. So nitrogen, being in group number 5, has 5 valence electrons on the outside. If I make just one single bond between these, so let's say I try and fill this hole right there and I join these two together. If I count the number of electrons, 1, 2, 3, 4, 5, 6, this nitrogen only has 6 on its outer ring that's being shared. So I need to make more bonds. So let's take these two and draw them together. So now if I count them, I have 1, 2, 3, 4, 5, 6, 7. Getting closer. Take another pair and connect them together. So now let's count. We have 1, 2, 3, 4, because they're being shared, 5, 6, 7, 8. Wow, that took a lot of bonding to put two little nitrogen atoms together. Shorthand notation, I'm going to use 3 lines. And yes, this is called a triple bond. So triple bond would be 3 lines. If I had something that was 2 lines, I would call that a double bond. So sometimes elements might have to make more than one bond with each other to fill their rings completely. Lastly, we have polar molecules. These are unequal sharing of electrons. The picture below is showing you the cloud where electrons could be. Notice around the hydrogen it's very tiny, and around the oxygen it's very, very big. So water creates what we call partially charged atoms, causing these hydrogen bonds over here that you see by these dotted lines. Because these electrons spend a little bit less time around the hydrogen, we're going to call the hydrogen partially positive, not completely positive, just partially positive. The oxygen then, since our electrons spend a little bit more time with the oxygen, we're going to call the oxygens partially negatively charged. So see you tomorrow.